This is where we left off in Chapter 7. For some reason, my videos aren't letting me record anything more than 15 minutes today, so I guess it doesn't like my space. So we're talking about the shell method because we're wanting to go around this line x equal to 4. So it's basically like a y-axis. So if we were going to use the washer method, we would need everything in terms of y. I don't want to solve these and give them in terms of y. This one wouldn't be bad. This one would be kind of crazy. So I don't want to do that. So we're going to use our shell method, which says we need to find our distance here and multiply by the distance here. So this p of x is my distance here, so my full length would be 4, and we're going to subtract whatever x is. So if x is 1, then this distance would be 3. If x would be 2, this distance would be 2. Now my height is just my top one minus the bottom one. So here would be the top one. This is the bottom, so we end up with this. Okay, so now when we're finding our volume, we're going to say 2 pi. We're going to go 4 minus x to 4x minus 2x squared dx. And we're looking at, again, these x values. I'm starting at 0, and I'm going to go to 2. So 0 to 2. So now we need to multiply that out. So let's say that's going to be 16x minus 8x squared minus 4x squared plus 2x cubed. Okay. So let's simplify that. So that's going to give me 16x minus 12x squared plus 2x cubed. So let's take the antiderivative. So I've got 16x squared over 2 minus 12x cubed over 3 plus 2x to the 4th over 4, and we're going to plug in 0 to 2. Oh, there we go. So if I plug that in, this is 8, 2 squared is 4. It's 4 times 8. That's 1/2 times 16. When I plug in 0 again, everything's 0. So let's see. These two are going to cancel. That's going to give me 8 times 2, so it's going to give me 16 pi. So that would be my answer for my area. Okay, so that's the difference between the shell method and the washer method. So if you're kind of going around the axis that your variables are already in, so if everything's in terms of x and you're going around the x-axis, then you want to use the washer method. If your variables are x and you're going around the y-axis, then you want to use the shell method. That kind of makes things a little easier. So now let's talk about work. So we're going to talk about arc length. I'm jumping ahead of myself. So arc length, we've got a formula for that. So if we want to know what our distance is of a curve, we can't really use our distance formula because that's not going to, a distance formula would be for a straight line. So we want the distance of a curve, we're going to use an integral. And it is integral from a to b, the square root of 1 plus, we could take our derivative and square it. Okay, so we're going to take the derivative function, square it, and plug it into this. Okay, so say I have y equals 3/2 x to 2/3, and I want to find the arc length from 1 to 8. Okay, so this is my a, this is my b. So now I just need to take the derivative of this, plug it in, and square it. So my derivative, I've got 3/2 times 2/3 x, and if I subtract 1 from this, it's going to give me negative 1/3. Alright, so my integral is going to be from 1 to 8. Got 1 plus, these would cancel, so it's going to give me x to the negative 1/3, so it's 1 over x to the 1/3. So 1 over x to the 1/3 squared. Alright, so let's try to simplify this. So this is x to the 2/3 down here, so let's add those together. So I would have x, let's say x to the 2/3 This is x to the 2/3 plus 1. Okay, just using a little bit of algebra. Now I can take the square root of this piece, and I get x to the 1/3. On top, I've got the square root of x to the 2/3 plus 1. All right. So we want to take the antiderivative of this. So anytime that I see anything that's complicated, I'm going to think u substitution. So if I let u equal this piece here, so I've got x to the 2/3, just what's under the square root. I don't want to deal with that square root. Then I take my du, so it's going to give me 2/3 x to the negative 1/3, which is nice because this is going to give me x to the negative 1/3. So I don't want the 2/3, so I move that over. And so now I'm going to have 3/2, my integral. This is my du. So I've got the square root, so I'll make it to 1/2 power of u. So let's go ahead and plug these points in. So if x is 1, u is going to be 1 to the 2/3 plus 1, so that's going to give me 2. Slide that over. If x is, what's the other one, 8, I have u 8 to the 2/3 plus 1, so that's 4 plus 1 is 5. So we're just going to plug in 2 to 5. So now let's take the antiderivative of this. So this is u, I add 1 to this, that's 3/2 divided by 3/2 from 2 to 5. So those two would cancel, so I have 5 to the 3/2 minus 2 to the 3/2, which ends up giving me, there's 3 5s, so that's 5 root 5 minus 2 root 2, and that would be our answer. If we wanted a decimal, we could plug that in our calculator and see what it is, but this would be our exact answer. Okay, so let's do one more like that. Okay, let's see, let me flip my paper over. So say I have, again, let me go ahead and write my formula up here. A to B, square that dx. So say I have the natural log of sine of x, and we're looking from pi over 4 to 3 pi over 4. Okay, so what I need to do is take the derivative of this. So the derivative of natural log is 1 over sine times the derivative of sine, which is cosine. So this is cotangent. All right, so let's plug that in. So I've got from pi over 4 to 3 pi over 4, square root of 1 plus cotangent squared of x. Okay. So I don't really like this because if I let u equal this, I don't have anything out here to be my du because I know my derivative would involve trig functions. But if I remember some of my trig identities, this is the same thing as that. Slide it over so you can see it. So let's try to do that. So I've got this 1/4 to 3 pi over 4, the square root of cosine squared x dx. So that's going to be nice because those can cancel. So it's going to give me pi over 4, 3 pi over 4, cosine of x dx. Okay, now cosine of x dx, that's not a rule that I remember, or an antiderivative I remember. But if I go back to section 5.2, which is, the rules are on page 333. So I go back to section 5.2. They tell me that the antiderivative of cosecant is the negative natural log of cosecant of x plus cotangent of x. And then I'm just going to plug in pi over 4 and 3 pi over 4. So I'm just going to type that into my calculator and get 1.7627 as my answer. Okay, so we don't, I wouldn't say you need to have that one memorized, but know where to find it. Know where to find those rules. Okay, so another thing from 7.4 was surface of revolution. Okay, well, let me see if I can find my notes. Okay, let me just find it in the book. Get an example for you. So surface of revolution, we're using the formulas. The formulas are on page 471, and the formula looks like this. So surface of revolution would be 2 pi from A to B of our radius times the square root of 1 plus derivative squared. So it's a formula very similar to our arc length. The only difference is we're multiplying by this radius. Okay? So say we have f of x is equal to